All right, welcome back to The Explainer. Today we are becoming geometric detectives. We're on the case to solve a classic and kind of mind-bending mystery.
So here's the central question, right? How can you prove, really prove, that two lines will never, ever meet? You and I can't just follow them out to infinity to see if they cross. So there's got to be a logical way to be 100% certain they're parallel.
And here's the thing. The secret isn't way out there in the distance. Nope. All the clues we need are hidden right here, right where the lines get crossed. The real evidence? It's all in the angles.
Okay, so Section 1, the parallel problem. We've got our mystery laid out for us. How do we prove these lines are parallel without following them forever? To crack this case, we're going to need a special toolkit filled with some undeniable geometric facts.
Which brings us to Section 2, clues in the corners. You know, every good detective has a reliable toolkit. Well, ours is going to be built on the most fundamental, rock-solid truths of geometry. These are the facts we'll use to build our entire case from the ground up. Okay, our very first tool is something called an axiom. Think of an axiom as a rule we all just agree is true because, well, it's just obvious. It doesn't need proving. And the big one for us is the linear pair axiom. It just says that if you have two angles sitting next to each other on a straight line, they always add up to 180 degrees. That's it. This is our first undeniable fact.
Now this is where it gets really cool. Watch how we can use that one simple axiom to prove something totally new. We apply that linear pair rule 2 times. Look, angle 1 and angle 2 are on a straight line, so they're 180 degrees. But wait, angle 2 and angle 3 are also on a straight line, so they're 182. See where this is going? If both pairs equal 180, they must equal each other. We just do a tiny bit of algebra, get rid of angle 2 on both sides, and boom, we've just proven with pure logic that vertically opposite angles are always equal. That's our first big break in the case.
All right, Section 3, investigating the transversal. It's time to head to the scene of the crime. When a third line, we call it a transversal, cuts across our 2 mystery lines, it creates 8 different angles. And for our investigation, you can think of these 8 angles as our persons of interest.
So this setup right here, this is our entire playing field. Everything we need to know is in this picture. The truth, are the lines parallel or not? It's all hidden in the relationships between these 8 angles. If we can understand how they relate, we crack the case. It's that simple.
First up, let's look for the F shape. Can you see it? The angles that are sitting in the same corners of that F have a special name, corresponding angles. They're in the same spot, just on different lines. Kind of like they're in matching chairs at 2 different tables.
Okay, next up, try to spot the Z shape. It might be a regular Z or a backwards one. The angles that are tucked right into the sharp corners of that Z, those are our alternate interior angles. They're on opposite or alternate sides of that transversal, and they're interior, meaning they're squished between the 2 main lines.
And last but not least, look for the C shape. The 2 angles trapped inside the C are called, you guessed it, consecutive interior angles. They're consecutive because they follow each other down the same side of the transversal, and they're interior because, again, they're stuck between those 2 lines.
So now, let's get into Section 4. What happens if the lines are parallel? For just a minute, let's pretend we already know the answer. Let's assume they're parallel. This is kind of like getting our hands on the suspect's secret playbook. It means we can predict exactly what all those angles are going to do.
And here's what that playbook says. If the lines are truly parallel, it's a guarantee. The corresponding angles will be perfectly equal. The alternate interior angles, also equal. And those consecutive interior angles, they won't be equal, but they'll be supplementary, meaning they'll always add up to a perfect 180 degrees. This predictable pattern, that's what we call a theorem.
Okay, on to our final section. Section 5, proving lines are parallel. Now remember, our job as detectives is actually the reverse of what we just did. We don't start by knowing the lines are parallel. We have to start with the evidence, the angles, and use them to prove our case. This is where we completely flip the script.
And this flip, this is the absolute key to everything. You see, a theorem works one way. It says, given that the lines are parallel, you can conclude the angles have these special relationships. But we need to go the other way. And for that, we use the converse. The converse says, given that the angles have these special relationships, you can conclude the lines are parallel. See the flip? The converse is our real detective tool. It lets us turn angle measurements into hard proof.
Okay, time to put this into practice. Case file number 1. We're on the scene, we've done our measurements, and we found a key piece of evidence, a pair of alternate interior angles, and they both measure exactly 55 degrees. So, they're equal. The big question is this enough to close the case? Are these lines parallel?
Yes, 1,000 times yes. Because we found a pair of alternate interior angles that are equal, the converse of the alternate interior angles theorem kicks in. It allows us to state without a shadow of a doubt that these lines are parallel. We've got our proof. Case closed. Awesome.
All right, on to the next one. Case file number 2. This time, our evidence focuses on the consecutive interior angles. One measures 100 degrees, the other is 70. Okay, let's do the math. That adds up to 170 degrees. So what's the verdict here? What does this piece of evidence tell our investigation? That's going to be a no. The lines are not parallel. Remember the rule? The converse theorem for these angles says they must add up to a perfect 180 to prove the lines are parallel. They're supplementary. But our evidence shows they only add up to 170. So the evidence doesn't just fail to prove they're parallel, it actually proves they aren't. These two lines will definitely cross somewhere down the road.
And so, here it is, your complete detective's toolkit for cracking any parallel line case. You just need one of these 3 things to be true. If you can show that a pair of corresponding angles are equal, the lines are parallel. If you can show that a pair of alternate interior angles are equal, the lines are parallel. Or if you can show that a pair of consecutive interior angles add up to 180 degrees, you guessed it, the lines are parallel. Any one of these is your smoking gun. It solves the mystery, every single time.
So, when you boil it all down, this whole investigation just shows how a few simple accepted truths, those axioms we started with, can be used to build an entire system of unshakable logic and proof. It's pretty amazing, right? And it kind of makes you wonder, now that you see this hidden logic in something as simple as lines, what other structures in our world are built on a similar foundation? You know, from giant bridges and skyscrapers to the complex code that's running on your phone right now. What other things are built on simple, powerful, undeniable rules?